Tonight, the universe feels a little different. The stars may look silent, distant, even peaceful. But what if that silence is not emptiness at all? What if it is caution? What if the reason no one answers is because every civilization in the galaxy already knows a terrible rule that humanity is only beginning to suspect? Among all the solutions to the Fermi Paradox, there is one theory more chilling than almost any other: the dark forest. A theory that suggests the universe may be full of life, and that staying hidden may be the only reason any of it survives. Before diving in, please take a moment to like the video, subscribe to the channel, and share it with someone who loves cosmic mysteries and science speculation. Thank you so much for being here and spending part of this quiet moment with the channel. And as always, it would be lovely to know, what time is it where the listener is, and from what part of the world is the listener watching tonight now? With that in mind, let us step into one of the most unsettling ideas in modern cosmic speculation and begin. In a forest on Earth, survival often belongs to the creature that makes the least sound, the one that cracks no branch, brushes no fern, disturbs no layer of dry leaves is the one that lives long enough to learn the deeper rules of the place. Life in such an environment does not advertise itself. It reduces its outline, it lowers its profile, it blends into shadow and pause and stillness. The forest does not forgive obvious movement for very long, because obvious movement becomes information, and information travels faster than the body that creates it. A scent lingers, a vibration spreads, a sudden noise marks a position. Somewhere nearby, another creature hears it, measures it, and turns toward it. This pattern is ancient on Earth, so familiar that it almost disappears into background instinct. Yet when humanity begins to look outward, beyond oceans and weather and continents, this old pattern remains. It simply scales upward into something colder. The same logic that governs a dark forest under moonlight may also govern a galaxy filled with worlds that cannot see one another clearly, cannot judge intention, and cannot afford to guess wrong. Human civilization does not behave as though this possibility matters. For a little more than a century, Earth begins to leak signals into space. First they are accidental, the stray byproduct of radio technology, military radar, television carriers, communication systems, and the endless electric chatter of an industrial species discovering how to turn thought into transmission. Then, gradually, some of the signals become deliberate. Powerful radio messages are aimed at the sky. Spacecraft are launched carrying records, diagrams, maps, and encoded traces of the beings who made them. Humanity does not merely become detectable. It experiments with self-announcement. It acts as though the unknown is likely to be curious, patient, and kind. It acts as though distance itself is a protection, or perhaps as though emptiness is already proven. The silence above Earth is interpreted in the most natural way if no one has answered. Then perhaps no one is there. But silence is a poor witness. Silence can mean absence. It can also mean restraint. It can mean failure, indifference, fear, or discipline. On Earth, the quietest places are not always empty places. Sometimes they are the places where life is most alert. A field full of birds can go silent all at once when something enters the air above it. A forest can still itself so completely that the stillness feels intentional. The galaxy presents that same unsettling stillness on a scale too large for instinct to pass. Telescopes look across immense distances and find stars in their hundreds of billions. Space observatories confirm that planets are common. The old image of lonely suns becomes obsolete. The universe does not appear barren. It appears crowded with possibility. Rocky worlds orbit in temperate zones. Gas giants drift with families of moons. Frozen bodies circle dim stars. Hot worlds, ocean worlds, worlds with thick atmospheres and worlds stripped almost bare, all emerge from the data. The broad pattern is no longer in question. Planets are not rare ornaments. They are part of the ordinary architecture of the cosmos. Once that fact settles in, a second thought follows almost immediately. If planets are common, then chemistry is common. If chemistry is common, then some fraction of those worlds should, under the right conditions, produce self-replicating systems. Over deep time, some smaller fraction should produce complexity. From complexity, perhaps sensation. From sensation, perhaps memory and tool use and organized intelligence. None of this needs to happen often. It only needs to happen more than once. The Milky Way is so large, and time is so deep, that even extraordinarily unlikely events should have repeated somewhere. Earth itself is evidence that matter can awaken into metabolism, adaptation, and thought. That single fact changes the sky. The question is no longer whether the universe permits life. It clearly does. The question becomes why that permission seems to have left no visible mark beyond one fragile world. That is where the quiet begins to feel strange. Humanity listens. Large radio telescopes sweep the heavens. Projects devoted to the search for intelligent life spend years combing through static, filtering interference, isolating peculiar signals, then discarding them when natural explanations return. Optical observatories search for signs of impossible engineering, for stars dimmed in unnatural patterns, for excess heat that could suggest giant energy harvesting structures around distant suns. Planetary science advances, exoplanet catalogues expand. NASA, ESA, ESO, and other scientific institutions map more of the sky with better instruments, better detectors, better software, better patience. The universe yields astonishing detail. It reveals black holes colliding, galaxies merging, planets transiting, atmospheres glowing with chemical signatures, and ancient light from the early cosmos still spread faintly across all directions. Yet on the narrow question that haunts all the rest, it yields almost nothing. No confirmed beacon, no unambiguous artificial structure, no measured sign of a civilization older and larger than humanity should expect to find in a galaxy this old. The paradox enters quietly, then refuses to leave. The math suggests abundance, observation returns vacancy. The sky does not look engineered. It does not sound inhabited. It behaves, at least from present human vantage, as though intelligence has either never flourished elsewhere or has left almost no trace. Many explanations are possible, and most begin conservatively. Perhaps life is rare at the first step. Perhaps simple cells are common, but complex multicellular life is not. Perhaps intelligence is an evolutionary fluke. Perhaps technological civilizations emerge and vanish quickly. Perhaps they become inward-looking, virtual, silent, or uninterested in expansion. Each explanation softens the contradiction a little, but none erases it entirely, because the scale involved is so vast that even narrow chances should eventually become visible outcomes. A more unsettling possibility begins where optimism ends. It begins with the thought that the silence is not a failure of life to appear, but a success of life in learning caution. It asks what a truly old civilization would conclude after enough time, enough observation, and enough exposure to risk. It does not assume alien minds resemble human minds in art, desire, humour, morality, or empathy. It needs none of that. It asks only what any long-lived civilization must understand if it wishes to continue. Survival comes first. Exposure creates vulnerability. The unknown cannot be trusted merely because it is distant. Distance may even worsen the problem, because distance delays understanding. A threat seen across light years cannot be questioned in real time. It cannot be reassured quickly. It cannot be studied without also revealing the act of study. Every signal sent outward is both message and map. It says not only that someone exists, but where. Seen from that angle, Earth begins to look less like a lonely island sending hopeful notes across an empty sea, and more like a campfire burning in a wilderness that is not answered, because answer itself may be dangerous. Human radio leakage forms an expanding bubble around the planet, a sphere of detectability growing year by year. It remains tiny against the diameter of the Milky Way, but it is no longer zero. That matters. The Arecibo message in the 1970s. The plaques and records attached to probes, the long tradition of active signalling. All of it carries the same assumption that contact is likely to be either harmless or transformative in a good way. Behind that assumption sits a deeper faith, rarely stated plainly, that advanced knowledge brings advanced restraint, and that intelligence tends toward cooperation once it matures enough. Perhaps that faith is correct. Perhaps the universe really is empty, or gentle, or too scattered for danger to matter. But perhaps that faith is only local, born from a species that has not yet encountered a rival beyond its own world. The fear in this theory does not come from monsters. It comes from logic stripped of comfort. If the galaxy contains many civilizations, and if at least some of them have learned that visibility invites risk, then the silence is no longer reassuring. It becomes strategic. It becomes the quiet produced when every watcher understands that being noticed may be fatal. In such a place, the absence of greeting is not evidence of peace. It may be evidence that the rules were learned long ago, and learned brutally. Humanity, still young enough to confuse silence with welcome, may have stepped into that old arrangement without recognizing it. The stars remain beautiful. The data remains incomplete. Nothing is proven. And yet the possibility settles in with unusual weight. The universe may be full of life that survives by doing exactly what Earth has not done at all. The numbers are what make the silence difficult to dismiss. If the sky above Earth contained only a few scattered suns, the loneliness of the universe would feel natural. If the Milky Way was small, young, and poor in planets, then the absence of company would barely require explanation. But the modern picture is nothing like that. The galaxy is immense. It contains somewhere between 100 billion and 400 billion stars, and that estimate does not even include the dim drift of rogue planets between them, or the faint populations at the edges where measurement grows uncertain. For most of human history, these stars are simply lights. Then astronomy becomes more exact. Spectroscopy reveals their composition. Precise measurements reveal their ages, masses, and motions. Observatories on mountain tops and in orbit begin to notice that many stars do not sit still. They wobble slightly, pulled by the gravity of unseen companions. Others dim at regular intervals as worlds pass in front of them. With each new survey, the old assumption weakens. Planets are not rare exceptions. They are ordinary outcomes of star formation. The shift is one of the most important in the history of science because it changes the background against which every deeper question is asked. Once, it is possible to imagine Earth as a singular accident. Now that position becomes harder to hold. The Kepler Space Telescope helps transform this view by revealing thousands of candidate planets and showing that worlds of many sizes and temperatures are common throughout the galaxy. Later instruments refine the picture. Some planets are larger than Earth but smaller than Neptune, a class not represented in the home system around the Sun. Some are rocky and close to their stars. Some orbit red dwarfs in compact systems. Some travel around twin suns. Some appear in regions where liquid water could, under the right conditions, persist on the surface. The details vary, But the broad lesson remains. Nature builds planets easily and often. It does not reserve them for special occasions. That abundance by itself does not prove life. But it changes the odds. Life on Earth appears surprisingly early in the planet's history, at least in simple form. The surface cools, oceans gather, chemistry stirs, and within a geologically short span the first signs of biology emerge. The exact pathway remains uncertain, and the origin of life is still one of science's hardest unsolved problems. But the timing matters. Earth does not seem to spend most of its habitable life waiting for the first spark. The spark, whatever it is, may happen readily once the conditions settle into a narrow workable range. This does not mean life is common. It means the first barrier may not be impossibly high. And if that barrier is not impossibly high, then the galaxy has had many opportunities to cross it. Time then makes the problem much sharper. The universe is about 13.8 billion years old. Earth forms about 4.5 billion years ago. Between those two dates lies an immense stretch of cosmic history. There are stars in the Milky Way far older than the Sun. Some stable, long-lived stars begin shining billions of years before the solar system forms. Around some of them, planets likely settle while Earth does not yet exist. On those worlds, if conditions permit chemistry, then life could begin while the future human species is still impossible even in principle. This means that humanity does not enter an empty stage. It enters a theatre that has already been open for an unimaginably long time. Even a civilization with a head start of 1 million years would stand so far beyond current human capability that comparison begins to fail. 1 million years sounds vast on human scales, but against cosmic time it is a thin margin, almost nothing. Yet almost nothing is enough to transform stone tools into industry, industry into computers, and computers into machines that touch the edge of the solar system. Given enough continuation, almost nothing may be enough to transform a planetary species into something that can reshape star systems. This is where the paradox turns from abstract to personal. If Earth is not special, and if many stars are older than the Sun, and if at least some habitable worlds exist elsewhere, then one might expect the galaxy to show evidence of age layered upon age. A civilization with immense time behind it would not need faster-than-light travel to become noticeable. That is one of the most unnerving parts of the argument. The speed of light is a hard limit in modern physics, and interstellar distances are brutal. Yet even with that limit intact, a species that spreads gradually could still move through the galaxy on timescales far shorter than the age of the Milky Way. It would not need to rush. It could send slow ships carrying settlers, machines, seeds of industry, or self-replicating probes that arrive in one system, build copies of themselves from local material, then continue onward. Each step might take centuries or millennia. The full process might take a few million years, perhaps more depending on the method, the goals, the failures, and the willingness to expand. But a few million years is a short chapter compared with billions. If anyone begins such a process deep in the past, then by now the results should be difficult to hide. The expected traces need not be dramatic in every case, yet some should exist. A civilization using energy on truly vast scales might alter the light of its star. It might build collectors, habitats, or industrial swarms that absorb part of a sun's output and re-radiate waste heat in ways astronomy could, in principle, detect. Freeman Dyson proposes a version of this long ago, not as fantasy but as an attempt to think practically about what advanced engineering might look like from far away. The idea is simple. Any large activity produces heat, even if a civilization remains invisible in every other respect. Thermodynamics may betray it. Search strategies inspired by this thought look for stars or regions with unusual infrared signatures. signs that energy is being harvested on scales beyond planets. So far, none provide clear proof. There are always natural explanations: dusty environments, stellar variability, instrumental limits, and the persistent human habit of finding apparent anomalies that fade under better data. Radio offers another path. Humanity itself becomes radio visible almost as soon as it enters the modern era. It is reasonable to ask whether other technological species do the same. For decades, the search for signals from intelligent life examines narrowband transmissions, repeating pulses, and other patterns unlikely to be produced by natural astrophysical processes. There are moments of excitement. A strange signal appears, then vanishes. A burst seems unusual, then resists interpretation. The famous fast radio bursts discovered in recent decades briefly stir imagination because they are intense and brief and arrive from distant galaxies. But the evidence points toward natural origins involving compact stellar remnants and extreme magnetic fields. Again and again, nature proves capable of making phenomena that feel artificial at first glance. The universe is stranger than expectation, but not necessarily inhabited in any clear way. The problem is not that there are no mysteries. The problem is that none of them settle into unmistakable intention. By now the contradiction has a shape. The galaxy should be old enough. It should be large enough. Planets should be common enough. Time should have provided many chances. Expansion, even if slow, should be possible. Detection methods, though limited, should perhaps have seen something, yet the sky stays stubbornly natural. Stars burn, nebulae glow, pulsars flash, black holes feed, galaxies collide, planets transit, atmospheres scatter light. The catalogue of known wonders expands almost monthly, but none of it resolves into the one discovery that would reset every human thought at once. There is no alien artifact drifting through the solar system. There is no engineered shell around a nearby star. There is no recognized beacon placed in the dark with the patience of something older than history. This absence is what makes the Fermi Paradox endure. The phrase is attached to Enrico Fermi, who famously asks a version of the question in the middle of the 20th century, "Where is everybody?" The force of the question lies in its plainness. It does not begin with mystical assumptions. It begins with quantity, time, and probability. It notices that if intelligent life is not extraordinarily rare, then at least some of it should have already crossed thresholds that humanity has barely approached. Once that is seen, every empty result grows heavier. Every silent survey becomes another piece of the same puzzle. The paradox does not prove danger. It does not prove loneliness either. It simply refuses to let the comfortable middle remain unexamined. Many proposed solutions attempt to preserve ordinary expectations. Perhaps intelligent life tends to destroy itself with war, ecological collapse, engineered pathogens, or uncontrollable machines before it reaches the stars. Perhaps simple life is common, but the jump to complex cells is so improbable that Earth is already an outlier. Perhaps consciousness itself is not useful enough for evolution to produce it often. Perhaps advanced civilizations become quiet by turning inward, living in digital worlds, reducing physical activity, and leaving little that distant astronomy can notice. Perhaps the galaxy is under observation in ways humanity cannot yet detect, a sort of controlled reserve in which young species are left undisturbed. These possibilities remain in play because none can be ruled out. But each one also shares a hidden burden. It must explain not one silence, but an enduring silence across a galaxy old enough to have tried many paths. That burden is what opens the door to darker reasoning. If the evidence does not favour abundance made visible, then perhaps abundance makes itself invisible. Not because invisibility is elegant, but because exposure is dangerous. At this stage, the argument is still only an opening, not yet a conclusion. The data does not force the dark interpretation. It merely permits it, and perhaps more than permits it. The same numbers that once encourage hope begin, under a different light, to imply caution. A crowded galaxy should be obvious unless crowded civilizations have compelling reasons not to be obvious. An ancient universe should be loud unless age teaches silence. The arithmetic does not change. What changes is the meaning of the void between the stars. It no longer looks merely empty. It begins to look withheld. The dark forest idea becomes truly unsettling when it stops depending on the details of alien biology. As long as the question is framed in terms of personality, the mind still has room to escape. One civilization might be peaceful, another curious, another detached, another compassionate. The imagination can distribute motives across the stars the way it distributes weather across a continent. Somewhere there may be danger, but elsewhere perhaps patience, restraint, or generosity. That line of thought is comforting precisely because it remains open. It assumes the unknown can contain any number of favourable traits. Yet the theory that gives the dark forest its force takes a harsher route. It removes almost everything that feels culturally specific and asks what must be true for any civilization that survives long enough to matter. It does not ask whether alien beings appreciate beauty, or form families, or grieve their dead, or dream of exploration. It asks only what constraints reality imposes on every species that reaches outward into space. From that stripped framework, two basic axioms emerge, and both are so plain that they seem harmless at first. The first axiom is that survival is the primary need of civilization, not the only need, not the noblest need, but the one that underlies all others. Any society may have art, faith, ritual, curiosity, pleasure, law, and memory. But all of these presuppose continued existence. A civilization that does not defend its own continuity will not remain a civilization for long. This is not a moral claim. It is a filter. Over long spans of time, whatever does not prioritize survival tends to disappear, whether through accident, internal weakness, complacency, or external threat. The universe does not grant exceptions because a species is admirable. It does not preserve the gentle for their gentleness. It does not reward openness merely because openness is beautiful. Stars flare. Worlds freeze. Asteroids strike. Ecosystems fail. Competitors arise. Intelligence that persists through these conditions is likely to be intelligence that learns, early or late, to protect its own line of continuity with unusual seriousness. On Earth, versions of this rule appear everywhere. A single organism preserves itself against injury, starvation, predation, infection. A population preserves itself through reproduction, territory, adaptation. Human civilizations, despite their ideals, devote immense effort to food security, infrastructure, medicine, surveillance, defense, and resource control. Even during peaceful eras, institutions are built around vulnerability because vulnerability never vanishes. Nations store reserves. Armies exist in peacetime precisely because threats may emerge with little warning. None of this proves that extraterrestrial life behaves like humanity in detail. It only suggests that persistence requires caution. If an alien civilization endures for thousands, tens of thousands, or millions of years, then some version of self-preservation must sit at its core. Otherwise, its history ends before it becomes visible across interstellar distance. The second axiom is less intuitive, but just as important. Civilization continuously grows and expands, while the total amount of matter and usable energy available to it is finite. Growth here does not mean simple population increase. though population may be part of it. It means the broader tendency of life and intelligence to enlarge their capabilities. A civilization that survives usually seeks more energy, more stability, more raw material, more computational power, more redundancy, more room for its descendants, more buffers against disaster. Even if it does not desire empire in any theatrical sense, it still requires throughput. The smallest village on Earth depends on flows of energy and matter. A technological civilization depends on them at scales that become harder to conceal and harder to satisfy. Industry, science, defense, transport, climate control, medicine, and long-term survival all demand access to resources. On a single planet, these demands eventually encounter limits. Space appears to solve that problem by opening outward. Asteroids can be mined, moons can be settled, gas giants can be harvested, stellar energy can be captured with increasing efficiency. But every step outward expands appetite as well as capacity. This is why the universe, though vast, does not automatically become spacious in a strategic sense. Its total matter is not infinite. Its stars are numerous but countable. Habitable environments are scattered and unevenly distributed. Some regions are rich, some poor, some violent, some stable only for a while. A civilization that masters interplanetary activity may quickly learn that its local system contains enormous wealth compared with any planetary surface. Yet it may also learn that long-term security encourages broader reach. More systems mean more redundancy. More redundancy means better survival odds against catastrophe. Once that logic begins, expansion no longer looks like vanity, it looks like insurance. To remain confined may be elegant in theory, but it may also leave a species one accident away from extinction. The drive outward can therefore arise not from conquest in the human historical sense, but from the simple mathematics of persistence. When these two axioms are placed together, a quiet transformation occurs. Survival is primary. Growth seeks resources. Resources are finite. From this alone, competition becomes possible even before hostility enters the picture. Two civilizations need not hate each other to become dangerous to one another. They only need overlapping futures. On Earth, this pattern is familiar. Animals competing for territory do not require ideological conflict. Plants competing for light do not require malice. Markets compete for materials, states for water, industries for land, species for ecological niches. Conflict emerges from intersecting needs inside constrained environments. The dark forest argument scales that pattern to cosmic size. If multiple civilizations expand through a finite galaxy, then eventually their spheres of interest cross. At that crossing point, resource competition is no longer hypothetical, it becomes structural. One response is to say, the galaxy is so enormous that no collision need ever occur. This seems reasonable at first. Distances between stars are staggering. Even neighboring systems are separated by vast gulfs that current human technology would take generations to cross. Yet the relevant comparison is not between one life and one voyage. It is between deep time and repeated activity. A civilization that persists for millions of years need not leap across the galaxy in one movement. It can proceed gradually. It can fill nearby space, then adjacent space, then farther regions in patient waves. Even if only a fraction of civilizations choose this path, the long duration available means their effect should accumulate. Finite resources need not be scarce in the human sense to generate tension. They only need to be desired by multiple growing systems over long enough periods. In such a framework, the galaxy is not an endless wilderness. It is an environment with enough room for expansion until there is not. The trouble grows deeper because expansion itself magnifies asymmetry. A civilization that gains access to more energy can develop more technology. More technology can improve expansion, defense, and detection. Improved detection can reveal other civilizations earlier. Earlier discovery creates more decision points. In effect, growth does not merely increase wealth, it changes the strategic map. The side with more resources may not become morally worse, but it becomes more capable of acting first and at greater distance. The weaker civilization, if detected, faces a future in which its present weakness is temporary, but its present vulnerability is immediate. The stronger civilization sees not only what the weaker one is now, but what it may become if left alone long enough. This alone would make the situation uneasy. Combined with the first axiom, it becomes colder. If survival comes first, then potential future threats matter almost as much as current threats. At this stage, the theory has still not claimed that all civilizations are naturally violent. That is one reason it feels more durable than simple fear. It does not depend on universal cruelty. It depends on universal stakes. Even a civilization that values peace may find itself embedded in conditions where peace cannot be verified. Even a civilization with no instinct for conquest may understand that other expanding civilizations reduce the margin of safety available to it. If one side harvests a system, that system is no longer open to another. If one side develops faster technologies, the balance of future power shifts. The universe becomes a place where intentions are hard to know, but capacities are impossible to ignore. Over enough time, strategy begins to matter more than sentiment, because strategy is what determines whether sentiment can survive at all. This is the point where the language of zero-sum thinking begins to appear. The phrase can sound too rigid, because not all cosmic situations are pure contests. Some regions may be effectively uncontested for long periods. Some civilizations may choose inefficiency, limitation, or concealment over maximal expansion. Yet the dark forest argument does not require every corner of the galaxy to be under pressure all at once. It requires only that civilizations capable of survival understand the possibility of future competition as real and potentially fatal. Once that possibility is admitted, caution becomes rational, hoarding becomes understandable, secrecy becomes sensible, detection becomes dangerous. The cosmos stops looking like a neutral stage for discovery and starts looking like a board on which pieces move slowly, but consequences last for ages. Human thought resists this because it prefers stories about transcendence. It assumes that greater intelligence should loosen primitive drives, not sharpen them. There may be truth in that. Advanced beings may have forms of ethics so stable and expansive that conflict no longer interests them. But the axioms do not ask what is uplifting. They ask what remains true even if uplift occurs. A civilization may become wise and still require energy. It may become compassionate and still wish to endure. It may reject conquest and still calculate risk. The darkness of the theory lies precisely there. It suggests that the problem is not villainy. The problem is that finite reality can turn survival itself into a strategic pressure, and strategic pressure can silence even the most enlightened participants. Once the argument reaches this point, the silent sky changes character again. It is no longer just statistically surprising. It becomes legible in a new way. A galaxy containing many civilizations bound by survival and growth would not necessarily be loud with greetings. It might instead be tense with restraint. It might contain watchers who do not reveal themselves because revelation offers no clear benefit and many possible harms. The stars remain what astronomy says they are: spheres of plasma, furnaces of fusion, anchor points for planets and dust and gravity. but the space between them begins to feel occupied by calculation. Not visible calculation, not proven calculation, only the possibility of it. Still, that possibility is enough to shift the emotional balance of the paradox. What once appears as absence now begins to suggest discipline. What once feels empty starts to feel careful, and careful things, when they remain unseen for a very long time, are often the hardest things to survive. The first refuge from the dark forest is always psychology. It is tempting to believe the problem can be solved by guessing what alien beings are like inside, because motives feel easier to negotiate with than mathematics. If another civilization is benevolent, then perhaps there is no danger. If it is curious, perhaps it seeks knowledge rather than domination. If it is deeply advanced, perhaps it has outgrown the crude logic of competition altogether. This response is understandable because human beings interpret danger through faces, voices, gestures, and patterns of behavior. Even before language, the human nervous system reads intention from movement. It looks for hesitation, aggression, submission, calm, concealment, and invitation. Entire civilizations on Earth have been built around refining that ability into diplomacy, law, custom, ritual, and trade. Much of human peace depends on the assumption that other minds can be read well enough, soon enough, to prevent fear from hardening into violence. But the moment the question is expanded from Earth to interstellar distance, nearly every one of those tools begins to fail. No one knows what an alien mind would be. That ignorance is not poetic, it is absolute. On Earth alone, intelligence takes very different forms. Octopuses solve problems with nervous systems unlike those of mammals. Birds remember, plan, and communicate with capacities once dismissed. Social insects behave as though the colony itself is a larger organism built from smaller ones. Even among humans, cultures assign value differently, perceive status differently, encode obligation differently, and respond to uncertainty differently. This is still variation within one species from one world, one biosphere, one evolutionary history. An extraterrestrial civilization might emerge from conditions so unlike those of Earth that even the categories humans use to discuss intention become unreliable. It may not divide self from group in familiar ways. It may not treat death, territory, offspring, truth, or time the way humanity does. It may not have evolved under predator pressure. It may have arisen in oceans, beneath ice, in dense atmospheres, or around stars whose rhythms shape cognition in unfamiliar patterns. Its senses may not resemble sight or hearing. Its memory may be distributed. Its decision-making may be collective, recursive, or machine-assisted beyond recognition. Human language has no secure bridge to such minds, because human language is built from terrestrial assumptions. This ignorance has an odd consequence. It prevents both trust and hatred from becoming stable positions. It becomes difficult to say aliens would be kind, because nothing supports that expectation. It becomes equally difficult to say they would be cruel in any recognizable way. The unknown cannot be treated as a known villain, yet it also cannot be treated as a known friend. The available evidence, which is none, permits every fantasy and therefore secures none of them. That emptiness matters because in high-risk environments, uncertainty itself becomes a strategic factor. A civilization does not need proof of hostility to act cautiously. It only needs the inability to rule hostility out, on Earth. This principle appears in military planning, public health, disaster response, and cybersecurity. When consequences are large enough, even low probability threats command attention. The less reversible the damage, the less confidence is required before precautions begin. Across interstellar distances, the problem becomes more severe because the uncertainty is not momentary. It cannot be quickly reduced by closer observation, face-to-face contact, or real-time negotiation. A newly detected civilization on a distant world may be visible only through fragments, a strange atmospheric composition, unnatural night-side illumination, a radio leakage pattern, a thermal anomaly, a transit signature that hints at orbiting infrastructure, or something even subtler. Those fragments might confirm intelligence while revealing almost nothing about intent. They might indicate technology, but not values. They might show capability without exposing doctrine. They might even be ambiguous enough that intelligence itself cannot be established with certainty. In such cases, the discovered civilization becomes a problem in incomplete information, and incomplete information is one of the most dangerous conditions in strategy. A misread signal can be fatal, a delayed interpretation can be fatal, an assumption of goodwill can be fatal. But so can overt aggression if the target is stronger than it appears. Humanity already glimpses a weak version of this logic in its search for extraterrestrial life. Even in the absence of confirmed signals, every unusual observation generates competing interpretations. A dip in starlight suggests a planet, then a cloud of dust, then instrument noise, then some rarer natural process. A burst of radio energy looks improbable, then reveals astrophysical origins. A molecule in an exoplanet atmosphere raises interest, then caution, then debate over chemistry, contamination, and model dependence. Science progresses by resisting premature conclusions. But the dark forest thought experiment asks what happens when a civilization cannot afford to wait for perfect certainty. If the cost of being wrong is extinction, then the threshold for concern drops dramatically. Unknown intention begins to function almost like danger itself. The distance problem then cuts the last threads connecting uncertainty to reassurance. Light does not move instantly. Information arrives late by the very structure of the universe. A civilization 100 light-years away can only be seen as it was 100 years ago. Any signal sent in response will require another century to arrive, and another century for the answer to return. Even a simple exchange stretches across timescales during which governments can collapse. Technologies can leap forward, ideologies can transform, and biological or synthetic evolution can alter the very nature of the sender. A message that says peace may be true when it is sent and false by the time it is received. A promise may outlive the institutions that made it. A warning may arrive after the event it describes. Even silence is hard to read. It may mean indifference, ignorance, caution, or preparation. The speed of light does not merely slow conversation. It breaks the practical foundations of trust. This is one of the least intuitive parts of the theory, because human beings tend to imagine communication as inherently clarifying. On Earth, misunderstandings can often be corrected through more contact, more messages, more meetings, more observation, more channels, more transparency. Across stars, more contact may increase risk faster than it increases certainty. To speak is to reveal existence. To reveal existence is to reveal location, or at least direction. To sustain communication is to build a trackable pattern. A beacon is not just language, it is exposure repeated over time. This transforms communication from a bridge into a gamble. A civilization considering whether to answer an unknown signal has to weigh not only the content of the exchange, but the strategic consequences of being mapped, studied, and remembered. From here, the idea known as the chain of suspicion begins to take shape. Civilization A detects Civilization B. Perhaps the initial evidence is faint but convincing enough. A planet shows artificial spectral traces, or a region of space emits a patterned signal. At once, a faces a question with no reliable method of solution. Is B dangerous? The natural hope is that B may be peaceful, yet A cannot confirm that. Worse, A cannot confirm whether B sees A, or whether B will see A soon, or what B will conclude if it does. If A chooses not to act, B may continue developing, if B later becomes hostile. A may lose the advantage of surprise. If A chooses to signal peacefully, B may interpret the signal as surveillance, deception, or the first move of a stronger power. If A remains silent, B may independently detect A and arrive at the same fears. Every option is contaminated by ignorance. The problem becomes recursive almost immediately. Suppose A is peaceful. That does not solve anything. Because B cannot know A is peaceful, suppose B is also peaceful. That still does not solve anything, because A cannot know that B knows A is peaceful, and B cannot know that A knows B is peaceful. Each side can reason several steps ahead and see fear reflected back at itself. A may think, even if B means no harm. B knows I could harm them, and that knowledge may cause B to strike first. B may think the same. The loop feeds on uncertainty rather than aggression. It does not require any civilization to desire conquest. It requires only that each one value survival enough to fear the other's fear. In game theory, this resembles commitment problems and security dilemmas familiar from human geopolitics. But the interstellar version is harsher, because verification is nearly impossible, and reaction times are measured in decades or centuries. The existence of technological acceleration makes the uncertainty still more corrosive. A civilization observed as weak today may not remain weak tomorrow. Humanity itself illustrates the point. In a small sliver of time, it moves from pre-industrial transport to flight, radio, nuclear energy, digital networks, robotic exploration of other worlds, and telescopes capable of analyzing distant planetary atmospheres. From the viewpoint of an ancient external observer, this transformation may look almost instantaneous. A species that appears primitive at one observation interval may become strategically relevant by the next. This means that hesitation carries cost. Waiting for certainty is not passive. It is a decision that allows unknown capabilities to grow in darkness. At this point, the moral categories most familiar to human thought begin to blur. Preemptive action no longer looks like simple aggression. Silence no longer looks like shyness. Observation no longer looks innocent. Even patience can become threatening if the other side suspects it is only preparation. The chain of suspicion transforms every virtue into possible camouflage. A cautious civilization may appear calculating. A restrained civilization may appear deceptive. A quiet civilization may appear to be hiding its weapons. Once the logic takes hold, evidence becomes unstable because each signal can support opposite interpretations. Peaceful language can be a trap. Hostility can be deterrence. Withdrawal can be strategic concealment. Without shared institutions, shared history, or rapid communication, there is no trusted frame in which meanings can settle. That is why the problem of other minds becomes so central to the dark forest. It is not just that alien psychology is unknown. It is that unknown psychology persists under conditions where mistakes cannot easily be corrected and the price of error may be total. The galaxy then ceases to be a place where encounter naturally leads to understanding. Encounter may instead lead to spirals of defensive reasoning too cold to interrupt. Each civilization sees only fragments and is forced to make decisions about futures it cannot observe. Every discovery becomes double-edged. To find another intelligence is to gain information and lose security at the same time. To remain hidden is safe only until someone else is better at searching. To reveal oneself is hopeful only if hope is already justified, and there is no independent way to know that it is. Nothing in present science proves that civilizations think this way. The point is not certainty. The point is that the structure of interstellar contact allows this logic to exist, and once allowed, it becomes difficult to dismiss. The great silence then appears under a harsher light. Perhaps the reason the universe does not speak is not that it has no thoughts. Perhaps thought, once mature enough to recognize the true difficulty of other minds across cosmic distance, learns that the safest sentence is no sentence at all. Once suspicion enters the picture, the silence of the universe stops feeling passive and starts feeling tactical. It is one thing to imagine civilizations separated by distance and ignorance. It is another to follow that condition to its practical end. If survival is primary, if growth eventually creates overlapping futures, and if no civilization can reliably read the intentions of another across light years, then every encounter becomes a test with impossible stakes. In ordinary human thought, uncertainty encourages caution, delay, diplomacy, and observation. In cosmic sociology, uncertainty may encourage something colder. The more dangerous the unknown becomes, the more the burden shifts away from patience and toward control. At a certain threshold, the safest future is no longer the one in which trust is built. It is the one in which risk is removed before risk has time to mature. This is the point where the chain of suspicion hardens into something far more severe than anxiety. It becomes a logic of preemption. Civilization A discovers civilization B. The discovery may be distant, indirect, and ambiguous at first, but eventually the evidence crosses a threshold that matters. There is intelligence there. There is organized activity. There is a technological trajectory, and now faces a problem that cannot be escaped by goodwill. If B is peaceful, leaving B alone may seem morally attractive and strategically harmless. But if B is not peaceful, waiting may be fatal. Worse, B may be peaceful now and dangerous later, not because its moral character changes, but because its capabilities change. A civilization that can do nothing today may be able to do everything tomorrow if enough time passes. This means the true object of fear is not the present form of the other civilization, but its future form. The threat is not what exists. The threat is what may emerge. Human history contains dim local analogies. States do not merely fear current military power. They fear industrial capacity, scientific progress, demographic trends, alliances, territory, and the speed with which latent strength can become active force. Entire wars on Earth are shaped not by immediate attack, but by calculations about who will become stronger if action is delayed. Yet even these comparisons remain too mild. Human states share a planet. They have embassies, spies, trade, migration, maps, shared biology, overlapping institutions, and, above all, the ability to exchange information in real time. None of those stabilizing conditions exist between stars. There is no global court for civilizations separated by 100 or 1,000 light years. There are no inspectors who can verify peaceful intent. There is no shared language that can be refined through repeated contact over a single week. There is only evidence delayed by light, interpretation distorted by distance, and the knowledge that any future conflict may unfold at scales no one can survive. From within that situation, preemption begins to look less like aggression and more like insurance. This is the brutal nerve of the dark forest theory, and the reason it refuses to fade once understood. The first strike, if successful, solves every ambiguity at once. A hidden civilization that destroys a newly detected rival does not need to decode its culture, monitor its growth, negotiate a border, or trust its messages. It simply removes an uncertain variable from the future. Such action is monstrous by ordinary human standards. But cosmic sociology does not ask what is noble. It asks what is stable under existential pressure. If one civilization adopts restraint while another adopts preemption, the restrained civilization may eventually vanish from the strategic landscape. Over immense timescales, selection may then favor civilizations that survive by acting earlier and more ruthlessly than others expect. At first, this sounds too extreme to sustain. Surely many civilizations would reject such a doctrine. Surely some would choose coexistence. Surely some would hide. Others would wander. Others would remain planetary. Others would seek only knowledge. All of that may be true. The dark forest does not require uniform behavior in every species. It requires only that enough civilizations adopt enough caution for silence to dominate what can be observed. Even a galaxy containing a mixture of temperaments could become quiet if the penalty for public visibility is high enough. The peaceful would learn concealment because they fear the ruthless. The ruthless would hide because open dominance invites coalitions or detection by still older powers. The curious would remain discreet because curiosity itself broadcasts location. Over time, many paths converge on the same outward behavior. Silence becomes the equilibrium not because everyone shares the same heart, but because everyone shares the same vulnerability. The role of technology makes this equilibrium sharper. On Earth, distance can sometimes protect the weak. Oceans and mountains buy time. In space, technology steadily erodes the protection of distance. Better telescopes reveal finer signatures. Better computation extracts patterns from weaker data. Better propulsion shortens response times. Better automation allows machines to operate for centuries. Better weapons, in speculative though not impossible terms, may exploit physics in ways still beyond current human engineering, but still consistent with known principles. A civilization that remains visible while others improve detection invites future exposure. A civilization that waits to act may one day confront an adversary too advanced to challenge. In such conditions, strategic thought begins to privilege invisibility, deterrence, and selective elimination. None of these require hatred. They require only memory and foresight. Even the act of listening becomes morally unstable in this framework. SETI on Earth is usually imagined as passive and benign. To listen is not to threaten. To observe is not to invade. But from the perspective of another civilization that believes in the dark forest logic, listening itself may be part of targeting. A receiver can become a weapon system once coordinates are confirmed. A telescope can become the first stage of a strike. A signal interception can become a death sentence delivered centuries later. In that light, the distinction between discovery and attack narrows. A civilization that knows it has been found may reason that waiting is reckless. Better to act while the opponent remains uncertain. Better to disappear, relocate, camouflage, or destroy the witness. This possibility infects every stage of contact with strategic poison. Information no longer feels neutral. It feels armed. There is another reason the logic grows so severe. In ordinary human conflicts, surrender, deterrence, and compromise can still preserve some continuity. In an interstellar contest between civilizations separated by deep distrust, the imagined worst-case outcome is not occupation or tribute. It is extinction. A civilization cannot assume that a superior rival will merely contain it, because containment itself requires ongoing trust and supervision. It cannot assume defeat leaves room for recovery, because technological asymmetry may be overwhelming. Once the stakes rise to total civilizational loss, risk tolerance collapses. Low probabilities stop looking small. Small vulnerabilities stop looking acceptable. Strategies that seem excessive under normal politics start to look reasonable under existential arithmetic. The same mental shift appears in nuclear deterrence on Earth, where the scale of possible destruction distorts ordinary ethical intuition. The dark forest simply extends that distortion beyond planets and across eras. Some versions of the theory imagine weapons so advanced that a mature civilization can erase a younger one almost without warning. Others remain more conservative and assume only that long-range probes, relativistic impactors, engineered pathogens, self-replicating machines, or manipulations of local astrophysical conditions could make interstellar violence possible in principle. The exact mechanism matters less than the asymmetry it creates. The weaker civilization may not even know it is under judgment. It may continue building observatories, launching messages, cataloguing exoplanets, and wondering at the stars while somewhere far away its existence is being weighed as a risk. That image is one of the darkest the theory produces, because it turns innocence into vulnerability. It suggests that a civilization may be most endangered at the moment it feels most curious. This logic also helps explain why the universe, if inhabited, may not display obvious empires. Popular imagination often expects advanced life to spread visibly, covering regions of the galaxy with megastructures, energy collectors, or triumphant signals. But visible empire may be unstable in a dangerous cosmos. The larger and brighter a civilization becomes, the easier it is to locate, estimate, and target. A species that understands this may spread in quieter ways, using distributed systems, low-signature habitats, hidden industry, concealed probes, or compact infrastructure designed to blend into natural astrophysical noise. It may avoid patterns that stand out to distant observers. It may even suppress younger civilizations not out of greed for immediate resources, but to preserve a low-noise environment in which no unpredictable actor grows strong enough to reveal the region. The galaxy then no longer resembles a frontier. It resembles a minefield in which advanced players survive by leaving the smallest possible trace. This notion gives a new edge to the absence of obvious astroengineering. The missing Dyson spheres, the missing loud beacons, the missing traffic between stars may not indicate that no one reaches such levels. They may indicate that those who do either choose concealment or are selected against if they do not. An open civilization becomes a signal flare. A flare attracts attention. Attention introduces uncertainty. Uncertainty invites preemption. Over enough time, the visible tend to disappear. What remains are the hidden, the restrained, the misleading, and the silent. The forest does not fill with campfires. It fills with motion that never reveals its source. From here, even optimism begins to feed the danger. Suppose civilization A is genuinely benevolent and rejects first strikes. Suppose it sends messages of peace, detailed scientific knowledge, and evidence of restraint. Civilization B receives them centuries later. Can B trust them? The very sophistication of the message may increase alarm. A civilization capable of long-range communication, encryption, and patient coordination may be more advanced than expected. Its ethics may be real, but ethics offer no guarantee under changing conditions. Its apparent openness may be a strategy to lower defenses. If B chooses trust and A later changes, B pays the entire cost. If B chooses suspicion and destroys A, B survives at least one more uncertain future. The logic is ugly, but it is internally consistent, and internal consistency is enough to make the theory feel dangerous. Once this is seen, the silence of the sky acquires the texture of a held breath. Every empty survey becomes ambiguous in a new way. The lack of response to Earth's signals is no longer comforting. It may mean they have not been noticed. It may mean they have been noticed and judged irrelevant for now. It may mean the listeners are too far away. It may mean no one exists. Yet the dark forest interpretation lingers because it explains not just absence, but restraint. It imagines a galaxy in which civilizations learn that publicity is suicide, and where the first rule of survival is therefore simple beyond all elegance: do not be seen, and if something else is seen, do not let it remain uncertain for long. Humanity stands uneasily before that rule because it violates almost every hopeful instinct that accompanies the search for life. Science usually proceeds by illumination, disclosure, shared data, and widening circles of knowledge. The dark forest suggests that at cosmic scale, knowledge and exposure may pull in opposite directions. To know more is to risk being known. To announce discovery is to mark position. To grow more capable is to become more visible, and to become more visible is to become harder to spare. Nothing in current observation proves that the galaxy obeys this logic. It remains a theory, a model, a speculative frame. But it is a frame that fits too many shadows at once. In it, the great silence is not a gap awaiting a friendly voice. It is the stable result of civilizations that understand the cost of being first to speak. Fear in the dark forest does not come only from what another civilization is. It comes from what that civilization may become before anyone can react. This is where time itself turns unstable. Human beings often imagine progress as a staircase, broad and even, each step rising at a predictable pace. History seems to encourage that illusion when viewed from a great height. Stone tools give way to bronze, bronze to iron, sail to steam, telegraph to radio, vacuum tube to transistor, chemistry to nuclear power, early computing to machine learning, and so the sequence appears orderly. Yet the lived reality is far stranger. Technological change does not move at one speed. It lingers for long stretches, then surges. It accumulates quietly in tools, methods, measurements, and theories until some threshold is crossed, and then an entire civilization seems to lurch forward. The pace from one era to the next is not smooth. It compresses. It accelerates. It catches even the species producing it by surprise. On Earth, this pattern is unmistakable. For tens of thousands of years, human tools improve slowly compared with the leaps of the last few centuries. Then agriculture appears and reorganizes social life. Surplus allows specialization. Specialization allows institutions, written records, complex trade, metallurgy, mathematics, and large political structures. Later, the scientific revolution changes not just what is known, but how knowledge is built and corrected. Then the Industrial Revolution compresses power into engines, engines into networks, networks into factories, and factories into a civilization capable of altering the chemistry of an atmosphere. Within a brief interval of history, electricity spreads across cities, communication jumps across oceans, aircraft rise into the sky, antibiotics reshape survival, and nuclear physics reveals that matter itself stores terrifying amounts of energy. A species that spends most of its story close to the ground reaches the moon within roughly a century of mastering powered flight. That is not a linear trend. It is an explosion. Any sufficiently old observer would notice this. If an alien civilization watches Earth from afar, perhaps by studying atmospheric changes, industrial emissions, radio leakage, orbital activity, or reflected light patterns from the night side of the planet, it does not merely see a static snapshot, it sees a curve. At first that curve is almost flat, then it bends sharply upward. The planet that once shows only biology and weather begins to display artificial chemistry, synchronized transmissions, satellite constellations, and signs of energy use increasingly detached from natural cycles. The important fact is not the absolute power of the civilization at the beginning of this process, The important fact is the speed at which capability begins to compound. In a few centuries, perhaps less, a world that appears irrelevant can become difficult to predict. In a few more, it may become difficult to contain. That prospect matters because the dark forest is shaped by futures, not presents. A weak civilization today is not simply weak. It is uncertain. It is a field of possible trajectories. Some paths end in self-destruction. Some stall. Some turn inward. But some continue upward. And if they continue upward long enough, then every initial judgment becomes obsolete. A distant observer looking at present-day Earth would see a species that has not mastered interstellar flight, has no known ability to threaten another star system directly, and remains entangled in local politics and fragile planetary conditions. Yet the same observer, if it understands exponential progress, would not be reassured by current weakness. It would ask what Earth may become in 200 years, in 500 years, in 1,000 years. On cosmic scales, these are negligible spans. On technological scales, they are enormous. The distance between a wooden sailing ship and a spacecraft is small compared with the distance between pre-technology and even modest spacefaring capability. Yet humanity crosses that smaller gulf with startling speed once compounding begins. This is why mercy becomes strategically unstable in the dark forest. To leave a young civilization alone is not simply to spare something harmless. It is to permit an unknown future competitor to keep climbing. That competitor may remain peaceful forever, but this cannot be guaranteed. It may also become fearful, expansionary, defensive, wounded, fractured, or transformed by technologies that alter its motives beyond recognition. Even if its character remains constant, its power does not. A civilization that can do no damage at one moment may possess world-changing tools at the next. Eventually it may build self-replicating machines, deep space infrastructure, advanced computation, or energy systems that let it spread outward in ways impossible to reverse. An older civilization that understands this may conclude that there is only one truly safe moment to act against a potential rival before that rival becomes difficult to eliminate. The logic is harsh because it treats potential as threat. On Earth, this appears in softened form whenever states react not to present attack but to projected future balance. It appears when military planners worry about industrial growth, not just troop numbers. It appears when emerging technologies are feared before they are fully mature. Nuclear weapons produce the clearest analogy. A state does not wait until a rival has deployed overwhelming arsenals before treating the problem seriously. The danger lies in the window, during which deterrence is not yet stable, when the future is moving faster than diplomacy can absorb. The dark forest generalizes this problem beyond planets. The issue is no longer a neighboring nation acquiring missiles. It is a neighboring civilization, perhaps many light years away, moving along a curve of advancement whose upper limit cannot be seen. There is another complication. Technological growth is not just about making more powerful tools. It is about changing the relationship between information and action. Better sensors improve detection. Better models improve prediction. Better automation shortens response time. Better energy systems support larger projects. Better materials open new engineering paths. Better computation allows a civilization to simulate, optimize, and coordinate at scales previously impossible. Progress in one field spills into others. Once a civilization reaches a certain threshold, the branches begin feeding one another. Advances in physics improve propulsion. Advances in propulsion improve exploration. Exploration provides new resources. New resources support more research. Research improves manufacturing. Manufacturing scales detection and defense. The process becomes a network rather than a line. This is why a civilization can appear stable for long ages and then suddenly accelerate. The hidden pieces finally connect. From the standpoint of an ancient observer, this makes young civilizations particularly unsettling. A civilization in its pre-industrial stage may be legible. Its energy use is tied mostly to biology, biomass, simple combustion, and local geography. Its atmosphere changes slowly. Its surface lights, if any, are absent. Its signature blends with nature. Then, within what may look like an instant, combustion becomes industry. Industry becomes electronics. Electronics become orbital presence. And orbital presence becomes the early architecture of spacefaring life. What happens beyond that point is hard to forecast because the civilization begins to direct its own evolution. Biological limits no longer define the rate of change. Machines, computation, and engineering take over part of the adaptive burden. At that stage, the future becomes even less predictable than before because a species is no longer merely evolving. It is redesigning the conditions under which it evolves. This matters deeply to the dark forest because unpredictability is already the central danger. The chain of suspicion thrives on what cannot be known. Technological explosion ensures that what cannot be known grows larger over time. A civilization may be observed as modest, then become something wholly different before the next meaningful exchange is possible. The speed of light guarantees delay. Technological acceleration guarantees that delay is costly. A 100-year-old assessment of another species may already be irrelevant. A 200-year dialogue may be useless. By the time one side has interpreted the other's signal, the sender may have crossed several thresholds of capability, internal transformation, or expansion. Trust cannot keep up. Even fear may not keep up. The strategic environment becomes a race between information and change is often faster. In that light, the phrase technological explosion takes on a colder meaning. It is not only a description of innovation, it is a destabilizing force in cosmic relations. It makes every young civilization a time bomb of uncertainty. Leave it alone, and it may become a partner. Leave it alone, and it may become an enemy. Leave it alone, and it may simply become visible enough to attract still other watchers, thereby exposing an entire region. The risk is not confined to direct competition for resources. A rapidly advancing civilization can alter the information ecology of the galaxy. It can begin broadcasting. It can launch bright infrastructure. It can generate detectable waste heat. It can attract attention from distant actors who had remained silent precisely to avoid detection. In that sense, a reckless young species is not dangerous only for what it may one day do. It is dangerous for what its visibility may trigger around it. Humanity again becomes an uncomfortable example. In barely more than a century, Earth moves from early radio to a planet wrapped in electronic signals and orbital technology. Spacecraft leave the solar system carrying records of their origin. Deliberate messages are transmitted toward other stars. Telescopes grow powerful enough to detect exoplanets and begin probing their atmospheres. The same curiosity that reveals the possible abundance of life also increases Earth's own detectability. From a dark forest perspective, this is an extraordinary pattern. A young civilization has not only begun to rise quickly, it has begun to advertise itself before understanding the strategic landscape into which it is speaking. To an external observer trained by long survival, that combination may look less like innocence than like volatility. The speed of modern technological change on Earth adds another layer. Artificial intelligence, biotechnology, autonomous systems, advanced materials, quantum research, reusable rockets, and planetary-scale data networks all suggest that humanity is still near the beginning of its steepest ascent. Whether this ascent continues smoothly is uncertain. Civilizations can stumble, collapse, or destroy themselves. Yet uncertainty cuts both ways. An external observer cannot safely assume Earth will fail. It cannot assume stagnation. It must consider the possibility that within a few more centuries, perhaps sooner, humanity or its machine descendants could command energy and reach far beyond anything visible now. In the dark forest, that possibility alone is enough to create pressure. This is why the weak are not automatically spared. In ordinary ethical language, weakness often invites protection, pity, or at least postponement. In strategic dark forest language, weakness is a temporary condition attached to an uncertain future. A sapling is not judged only by its present height. It is judged by the shadow it may cast if allowed to grow. The metaphor is brutal, but it captures the logic. A mature civilization cannot rely on permanent superiority. It knows from its own history how quickly thresholds fall once compounding begins. It knows that intelligence, once bound to engineering, can transform across astonishingly short spans. It may therefore look at a planet full of primitive life and ignore it. But the moment that life develops science, industry, and outward awareness, the calculation changes. The harmless world becomes a possible future rival, and possible future rivals are among the most dangerous objects in the dark forest, because they still have time to surprise. Nothing in present observation proves that any civilization acts on such reasoning. The theory remains speculative, yet the pattern of human history gives the speculation unusual force. Earth demonstrates that technological trajectories can remain quiet for ages and then curve sharply upward. Earth demonstrates that a species need not be ancient to become detectable. Earth demonstrates that progress in one domain amplifies others until the whole system begins changing faster than intuition expects. If these truths are local, the dark forest weakens. If they are universal, it strengthens dramatically. The silence of the sky may then contain another hidden lesson. It may be the result not only of fear, but of timing. Civilizations that survive may learn to act before dangerous curves become too steep. They may understand that the safest rival is one still early in its ascent. In such a universe, the night does not remain quiet because nothing rises. It remains quiet because anything that rises too visibly may not be permitted to finish rising at all. By the time the dark forest metaphor fully settles into place, it stops feeling like metaphor alone. It begins as an image because images help the mind cross impossible scales. A forest at night is small enough to imagine. It has trunks, roots, undergrowth, pockets of shadow, and sudden lines of sight that open and close again. It has sounds that travel farther than expected, and shapes that cannot be trusted until they are near, and by then it may already be too late. Nothing in such a place is seen in full. Life reveals itself in fragments, a shifted branch, a brief outline, the pressure of movement through leaves, the flash of reflected eyes, the silence that appears where sound had been. The forest is not defined only by what lives in it. It is defined by how little can be known with confidence before a decision must be made. That is what gives the metaphor its force. It is not simply that the galaxy may contain predators. It is that the conditions of perception may make every other presence look like a possible predator. In ordinary daylight, uncertainty softens, shapes separate, distance becomes measurable, intent can at least be guessed from behavior. In darkness, the opposite happens. Categories collapse. A harmless figure and a lethal one occupy the same outline until more information arrives, and sometimes more information never arrives in time. The dark forest theory claims that cosmic distance creates exactly this condition. The stars are the trees. The void between them is the open ground through which signals and probes must travel. Civilizations move within that darkness with incomplete knowledge. partial maps, and strong reasons not to announce themselves. The result is not a grand galactic community waiting politely behind the veil of light years. It is an environment where survival depends on staying obscure long enough to judge, and on judging quickly enough to survive if obscurity fails. This is why the image of the hunter becomes central. The hunter in the dark forest is not a symbol of cruelty. It is a symbol of adaptation. A creature that survives in a dangerous forest does not move noisily because it enjoys fear. It moves quietly because quiet is what works. It does not reveal its location because revelation attracts attention. It does not investigate every rustle with perfect openness because some rustles conceal jaws or claws or venom. Over time, the forest selects for restraint, tension, and the habit of assuming that unseen things matter. The dark forest applies the same logic to civilizations. Those that remain visible, loud, and naive risk removal. Those that endure may be precisely the ones that learn concealment early and never unlearn it. The quiet sky then becomes less mysterious in one sense and more terrifying in another. It is quiet not because there are no hunters, but because all surviving hunters understand silence as a basic survival skill. The metaphor also changes how the old dream of exploration appears. Human cultures often imagine the cosmos as an ocean, open and waiting, a place of voyages, encounters, and widening routes between distant ports. That vision is hopeful because oceans, for all their danger, still permit trade, return, and the building of shared maps. The dark forest rejects that emotional geometry. It suggests that space is not an open sea at all. It is a dense and hidden place where the main danger is not storm or distance, but exposure. An ocean invites sails and signals. A dark forest punishes both. In an ocean metaphor, a lighthouse is a gift. In a dark forest metaphor, a light is a target. This is not a small change in mood. It is a complete reversal of the moral atmosphere of the sky. Under this reversal, many human instincts begin to look maladapted. Curiosity, display, and communication are among the traits that drive scientific civilization forward. Humanity learns by asking, broadcasting, sharing, comparing, and inviting response. Knowledge expands through visibility. Journals publish. Telescopes announce findings. Space agencies share imagery. Laboratories build on each other's work. Even rivalry between nations often accelerates openness at the level of result, because proof must be shown to matter. This culture of disclosure is a strength on one planet where shared reality can, at least sometimes, be coordinated. In a dark forest, the same instinct may be catastrophic. The desire to know and be known may function like a biological weakness, the equivalent of bright coloration in an environment full of predators. What looks noble from within the species may look reckless from outside it. The forest image sharpens this by removing the possibility of neutral spectatorship. In the ordinary human imagination, a civilization might hide peacefully while others expand carelessly, observing from safety. But a true dark forest contains no permanently safe vantage point. Every watcher is also potentially watched. Every listener knows that listening leaves traces if the tools become powerful enough. Every silent civilization must assume that somewhere beyond its own horizon, older and more capable entities may already exist. This creates layers of concealment nested within other layers. The young fear the old fear whatever may be older still. Even strength offers no full relief because strength increases detectability. Large industry creates heat. Large infrastructure creates patterns. Large communication networks create noise. Power solves many local problems while creating one universal problem it is difficult to hide. From here the metaphor gains another dimension. The forest is not populated only by direct hunters, it is populated by echoes, old ruins, false signals, and traces that may or may not indicate present danger. On Earth, a broken branch does not say whether the animal that broke it remains nearby. A scent on the wind may be fresh or fading. The dark forest version of this uncertainty appears in the search for anomalies across space. A strange dimming event around a star, an unusual radio burst, an odd thermal signature, a peculiar orbital pattern. Any of these may draw attention precisely because they are fragments. But fragments are dangerous because they cannot tell whether they are remnants, natural phenomena, accidents, bait, or the visible edge of something larger and hidden. In a galaxy shaped by caution, even evidence becomes suspect. A beacon may be a trap. Silence may be camouflage. Disorder may be deliberate masking designed to resemble nature. That possibility does something important to the emotional structure of the theory. It means the universe does not need to be filled with overt violence for the dark forest to hold. It only needs to contain enough danger that ambiguity itself becomes weaponized. Every civilization then confronts a terrible informational poverty. It must decide whether to remain still, whether to probe, whether to flee, whether to signal, whether to strike, whether to pretend absence, whether to cloak activity under natural-looking signatures, whether to scatter into smaller habitats, whether to build decoys, whether to suppress all detectable leakage. Over time, the strategic cultures that endure may come to resemble each other from the outside, even if they are internally different in every other respect. They all go dark, they all step lightly, they all learn not to light fires. This also explains why the metaphor feels more chilling than simpler versions of cosmic hostility. An openly hostile universe is, in a strange way, easier to imagine. It has enemies, empires, invasions, fronts, victories, losses. Such a universe still contains action that can be narrated. The dark forest is colder because it is built on restraint. The worst danger is not a roaring armada. It is a silence so disciplined that almost nothing is seen until the relevant decision has long been made elsewhere. It is the possibility that civilizations do not conquer flamboyantly. They prune quietly. They remove threats before those threats ever become scenes. No one hears the shot because the shot may arrive as absence, as the disappearance of a signal, as a world that fails to progress, as a region that remains oddly empty generation after generation. In that sense, the forest is frightening not because it is full of obvious monsters, but because its methods leave so little to observe. Humanity's own observational situation fits this in unnerving ways. The sky, as currently known, looks overwhelmingly natural. There are galaxies, stars, planets, asteroids, comets, plasma jets, supernova remnants, neutron stars, black holes, molecular clouds, and the faint afterglow of the early universe. There are astonishing events on every scale, yet all of them fit within physics as presently understood. Even when the details are not fully solved, the cosmos reveals immense power but little clear intention. To many scientists, that simply means nature is sufficient to explain what is seen, and that remains the most disciplined position. But inside the dark forest framework, this same natural appearance becomes eerie. A successful civilization would have reason to leave the sky looking natural. The ideal camouflage is not invisibility in the absolute sense, it is indistinguishability from background reality. To hide a structure, make it look like dust. To hide activity, spread it thinly or bury it in expected noise. To hide existence, let physics speak louder than any design. The forest metaphor also carries a final cruelty. In a real forest at night, the creature that makes noise may believe it is calling for help. It may not understand the audience it has created. It may assume that hearing implies sympathy, because among its own kind, sound often summons protection or companionship. But the forest contains many ears not bound by that assumption. The call travels impartially. It does not choose who receives it. The dark forest says Earth may occupy exactly this position. Human messages toward the stars are framed by hope, science, art, mathematics, and the wish not to be alone. Yet once released, signals do not preserve intention. They preserve only information and location. Whoever hears them hears what can be exploited, not what was meant. A map meant as greeting remains a map. A declaration of peaceful curiosity remains proof that a civilization exists at a particular world around a particular star. Seen this way, the old silence of the cosmos acquires a terrible kind of dignity. It may represent a learned discipline older than human history, perhaps older than the human species itself by spans too large to hold in one thought. Civilizations arise, discover the sky, imagine companionship, and then, if they survive long enough to understand the forest, they lower their voices, they shut down their fires, they fold their ambitions inward or redirect them into hidden forms. They continue existing, perhaps flourishing in ways invisible to distant astronomy. But they do not sing into the trees. They do not assume the darkness is empty. They do not mistake quiet for safety. The stars then cease to look like invitations. They look like points behind which entire survival strategies may be concealed. And yet the metaphor never fully closes the case. That is part of its power. It is vivid enough to explain the silence, but not provable enough to settle it. The forest may be dark because no one is there. It may be dark because life is rare, intelligence fragile, expansion unattractive, or detection harder than humanity assumes. Still, once the hunter image has been admitted, it clings to the night sky with unusual tenacity, because it matches something old in biological reality. On Earth, life often survives not by broadcasting virtue, but by minimizing notice. The universe has had far longer than Earth to discover effective strategies. If silence is one of them, then the beauty of the stars may conceal not a welcome, but a rule. Move carefully, speak rarely, assume the shadows are occupied, and understand that whatever survives in them has likely survived precisely because it has already learned these lessons better than anything young enough to still be calling out. When the theory turns back toward Earth, it becomes harder to keep the fear abstract. So long as the dark forest remains a model for distant civilizations and ancient strategic logic, it can still be held at arm's length, examined as an intellectual structure, compared with alternatives, and set aside when needed. But the moment humanity is placed inside it, the entire argument changes temperature. The question is no longer what advanced life elsewhere might do. The question becomes what Earth has already done, what signals it has already released, and whether a young civilization may have begun announcing itself before it has any idea what sort of universe receives announcements. Seen from inside ordinary human optimism, the modern search for extraterrestrial intelligence looks noble, curious, almost inevitable. Seen from the dark forest, the same behavior begins to resemble exposure without reconnaissance, visibility without cover, a flare raised into unknown darkness by a species that has not yet learned that darkness may be populated. Earth has not remained quiet. Long before deliberate messages are sent, industrial civilization begins radiating evidence of itself into space. Radio broadcasts, military radar, communications arrays, and high-power transmissions spread outward at the speed of light, forming a growing shell around the planet. That shell remains thin relative to the galaxy, but it is real. If some sufficiently sensitive observer were positioned within range and happened to be listening on the right frequencies with the right assumptions, then Earth would not be perfectly hidden. Over time, the details of human leakage change, analog television fades in some regions, signals become more compressed, directional, and efficient. Radar systems vary. Satellite constellations multiply. The exact detectability of Earth at long distances is debated because signal strength falls off rapidly and background noise complicates recovery. Yet the dark forest does not require certainty that Earth is already loudly visible across huge stretches of the Milky Way. It requires only that humanity behaves as though visibility is acceptable and sometimes desirable before the risks are known. That behavior becomes explicit in the age of deliberate messaging. The most famous example is the Arecibo message, transmitted in the 1970s from the Great Radio Telescope in Puerto Rico toward a distant star cluster. The message is not a conversation. It is more like a demonstration, a proof that intelligence on one world can arrange information in structured symbolic form. It encodes basic mathematics, elements of biochemistry, the structure of DNA, a stylized image of the human body, the population of Earth at the time, a diagram of the solar system, and a representation of the telescope that sends it. In practical terms, the message is unlikely to function as a near-term invitation. The target lies so far away that any reply, if one were ever possible, would take tens of thousands of years to return. For many scientists, the broadcast is therefore more symbolic than operational, an expression of scientific imagination rather than a genuine attempt to summon contact. But symbols matter in the dark forest because symbols reveal assumptions. The assumption embedded there is profound that to be known is not obviously fatal. That assumption appears again in the plaques attached to the Pioneer spacecraft and the records placed aboard the Voyager probes. These artifacts are among the most moving objects humanity has ever launched because they contain a compressed self-portrait of a species that has barely begun to leave its world and yet already imagines being understood by minds from elsewhere. The Voyager Golden Record carries sounds of Earth, music, greetings in many languages, and encoded images intended to describe the planet and its inhabitants. The plaque and the record both include locational information, a way to identify the Sun and the region of the galaxy from which the craft originated. The practical chances that another civilization will encounter these probes are extraordinarily small. Space is too vast, the probes too dim, their trajectories too sparse. Yet again, the practical odds are not the whole point. The deeper point is that humanity repeatedly chooses self-disclosure, as though self-disclosure is a virtue that scales upward into the cosmos unchanged. This choice emerges from a long cultural pattern. Human beings often link intelligence with moral advancement. The idea appears in secular and religious forms alike. The more a civilization knows, the less violent, narrow, and fearful it is expected to become. Advanced technology, in this imagination, implies advanced ethics, or at least restraint. A species capable of crossing the stars would presumably have mastered not only propulsion and energy, but also the social and moral disorders that make conflict destructive. It would not arrive as conqueror because conquest would seem primitive. It would not answer curiosity with annihilation, because such behavior would betray a form of immaturity inconsistent with long survival. This hope is so emotionally appealing that it often hides inside scientific discourse without being stated directly. The search for life is framed as discovery, not exposure, because the expected contact is assumed to broaden understanding, not end it. The dark forest challenges this hope at its root. It suggests that technological advancement may not erase strategic pressure, it may intensify it. A civilization does not become safe merely because it becomes capable. It may become more calculating, more aware of long-term risk, more conscious of how little can be known about distant others, and more committed to survival precisely because it has survived long enough to understand what survival costs. In that framework, a young species like humanity broadcasting its location is not admirable. It is dangerous to itself and potentially irritating or alarming to others. It is the behaviour of an actor that has not absorbed the hidden rules of the environment. From the human side, such messaging feels like openness. From the dark forest side, it may look like volatility, unpredictability, or even bait. This is one reason the debate over active messaging to extraterrestrial intelligence has never fully settled. Some scientists and thinkers argue that intentional transmission is a natural extension of the search for life, and that fear of hypothetical aliens is too speculative to justify silence. Others respond that the speculative nature of the threat is exactly what makes caution necessary, because once a message is sent it cannot be recalled, and the future consequences may fall on generations that never consented to the gamble. The disagreement reveals something unusual about humanity's position. For perhaps the first time in its history, the species faces a choice whose consequences may unfold not over years or centuries, but over intervals longer than any political institution, cultural identity, or even present language is likely to remain stable. To speak outward is easy. To predict what the speech enters is impossible. The decision is therefore made under radical ignorance, and radical ignorance is precisely the condition the dark forest treats as most dangerous. The expanding bubble of Earth's radio history sharpens the unease. Every year, signals from the early decades of human broadcasting reach new stars. The first shell of leakage grows larger, although weaker as it spreads. A sphere roughly 100 light-years in radius encloses the region that has, in principle, had time to receive Earth's earliest transmissions. That region contains thousands of stars. Not all are sun-like, not all have planets, not all would host listeners even if life is common, but the sheer fact of the sphere matters because it turns exposure into geometry. The human species is no longer merely wondering whether the universe can hear it. It is placing measurable volumes of space into the category of places that may already contain evidence of its existence. Most of that evidence is faint, scattered, and difficult to reconstruct. Yet in the dark forest, faint evidence may be enough if the listener is old, patient, and technically sophisticated. Even beyond radio, Earth is becoming more detectable in other ways. A civilization with extremely advanced astronomical capabilities might infer industrial activity from atmospheric chemistry, especially if a planet's gases drift out of equilibrium in ways biology alone does not explain. Chlorofluorocarbons, nitrogen compounds, artificial night illumination, large-scale orbital structures, unusual heat patterns, and other technosignatures are all discussed in modern astronomy as possible clues to life elsewhere. Humanity uses these ideas to imagine finding others, but the logic is symmetrical. If Earth can search for technosignatures, then Earth can also produce them. At present, most of these signatures would be extraordinarily difficult to detect across interstellar distances with human-level instruments, and there is no proof that any watcher is close enough or capable enough to notice. Yet the dark forest cares less about present proof than about direction of change. Earth is not becoming harder to detect, it is becoming easier. This creates a strange inversion in the story of progress. On one side, better technology promises deeper understanding of the cosmos. New observatories such as the James Webb Space Telescope help reveal exoplanet atmospheres, early galaxies, and the chemistry of distant worlds in astonishing detail. Future missions may push further, separating planetary light from starlight more cleanly, and perhaps identifying gases associated with biology or industry. From the human perspective, this is a triumph of knowledge. It expands the map of possible life. From the dark forest perspective, the same progress means that observational ability across the galaxy may also be improving elsewhere. Every step that allows Earth to notice others makes it easier to imagine others noticing Earth. Curiosity then becomes reciprocal, not in the friendly sense, but in the sense that every window opened outward may also function as a line of sight back inward. Humanity's cultural tone around the search for life adds another layer of vulnerability. Scientific outreach often presents contact as one of the grand hopes of the age, a discovery that would unify the species, redefine its place in nature, and perhaps dissolve some provincial myths. Popular culture moves between utopian teachers and apocalyptic invaders, but the scientific mainstream usually favors cautious optimism. There is good reason for that. Science works best when fear does not outrun evidence, and there is no evidence of hostile extraterrestrial intelligence. Yet the dark forest exploits precisely this reasonable discipline, because open danger has not been observed. Openness continues, because nothing answers. The silence is interpreted as benign or empty rather than strategic. Because no catastrophe has followed earlier transmissions, the habit of transmission begins to feel normal. Step by step, the absence of immediate punishment is mistaken for safety. In an ordinary environment, this would be sensible learning. Touch the flame, get burned, learn caution. If nothing burns, continue. But interstellar risk does not operate on human feedback loops. Consequences, if they exist, may arrive centuries or millennia after the initial act, long after the institutions that approved the act have vanished. The dark forest therefore exposes a cruel mismatch between human psychology and cosmic timescale. Earth behaves like a species calibrated for local cause and effect, while the possible strategic environment is one in which cause and effect may be separated by distances and durations far beyond intuition. A message sent in one century may be noticed in another, evaluated in a third, and answered in a fourth. From the human point of view, that feels almost irrelevant. From the point of view of a long-lived civilization, it may feel prompt. This is what makes Earth's position so unsettling within the theory. The species is young enough to be naive, advanced enough to be noticeable, curious enough to be loud, and fragile enough that any serious interstellar threat would exceed its ability to respond. It has begun the outward phase of civilization without first knowing whether the galaxy rewards visibility or punishes it. It has sent mathematics, images, music, biological diagrams, and locational information into a silence it still interprets through hope in a better universe. This may be remembered as the beginning of contact, the first tentative act of a species entering a wide community. In a darker universe, it may be remembered differently, if it is remembered at all as the moment a young world lit a signal fire before understanding what kind of forest surrounded it. By this point, the silence no longer feels like a simple lack of evidence. It starts to resemble evidence of a particular kind, not proof in the scientific sense, but a pattern whose shape becomes harder to ignore. The universe is not merely empty of obvious visitors, it is empty in strangely specific ways. It is empty of beacons, empty of unmistakable engineering, empty of the kinds of large-scale signatures that, in ordinary expectation, should accumulate if even a small fraction of civilizations decide to expand, harvest, and remain visible over long spans of time. The longer this absence persists under improving observation, the more uncomfortable the gap becomes. A natural question follows if the galaxy contains life. Why does it not show the metabolic heat, structural extravagance, and purposeful noise that intelligence on large scales ought to create? In other words, why does the cosmos look so thoroughly natural? Humanity has spent decades trying to answer that question indirectly. The search does not begin with alien ships or artificial voices. It begins with astronomy itself, with the assumption that any civilization using energy must obey the same broad physical rules as everything else. If a world develops industry, it emits heat. If it mines, builds, computes, manufactures, and expands, it must alter matter and irradiate waste energy in some detectable form. A civilization that encloses part of a star's output, redirects orbital bodies, or fills a system with habitats and collectors should, in principle, produce patterns different from those of untouched astrophysical objects. This is why astronomers search for technosignatures beyond radio. They look for excess infrared light that might indicate waste heat, for unusual transit curves that could hint at structured swarms, for orbital architectures that seem contrived, for atmospheric compounds that suggest industry, and for sources whose behavior resist the familiar categories of stars, dust, gas, and gravity. The results are always interesting, but they never settle into certainty. Natural explanations continue to win. There are moments when the possibility of artificiality briefly surges, a star dims in a peculiar pattern, and public imagination races ahead. Could this be a structure, a swarm, a shell, a sign of large engineering? Then more data arrives. Dust becomes likely. Instrumental effects are reconsidered. Additional wavelengths reveal behavior consistent with ordinary astrophysics. The anomaly retreats back into nature. Similar stories recur elsewhere. A signal seems narrow and intentional, then proves local interference. A fast burst appears unnatural, then folds into the violent but natural life of magnetized stellar remnants. An object enters the solar system on an unusual path, and for a moment speculation expands. Then natural models return to the front of the line. This process is healthy science. Nature should not be abandoned whenever something strange appears, but over time it leaves behind a broader impression. The strange things are real, yet they do not stay artificial. The universe remains baffling, but not openly inhabited. The absence of visible megastructures is especially significant in dark forest reasoning because it removes one of the easiest ways to imagine advanced life. If intelligence scales upward in the straightforward human sense, then one expects larger and larger interventions in matter and energy. Planets become systems. Systems become networks. Local engineering becomes stellar engineering. A civilization that wants more power eventually surrounds, shades, or otherwise exploits its sun. The idea is not fantasy. It is the simple extrapolation of growth under physical constraint. And yet when astronomers scan the sky, they do not find populations of stars clearly wrapped in civilization-scale machinery. They find ordinary stars, variable stars, dusty stars, young stars, dying stars, stars in crowded and uncrowded environments, but not the widespread unmistakable signs of industrial capture on the scale once imagined as inevitable. This does not prove such structures do not exist. They may be rarer, subtler, colder, more efficient, more concealed, or designed in forms humans have not anticipated. Still, their apparent absence adds pressure to the paradox. Radio silence adds a parallel pressure. Humanity invents radio and quickly understands its power. Information can cross continents, then oceans, then space. It becomes natural to imagine other civilizations doing the same. A beacon seems like the easiest possible announcement across cosmic distance. Yet decades of searching have yielded no confirmed interstellar transmission that clearly resolves into intelligence. The silence is not absolute in the literal sense. The universe is full of radio noise. Pulsars flash with perfect regularity. Quasars roar. Plasma jets hiss across millions of light years. Magnetars release extraordinary bursts. The cosmos is loud in physics and mute in intention. That distinction matters. Nature broadcasts constantly, but it does not greet. The sky produces spectacle without acknowledgement. In the dark forest. This is exactly what one might expect. Noise remains because stars and matter cannot help making it. Deliberate voice disappears because civilizations can help making it, and therefore can choose not to. This is where silence begins to look less like emptiness and more like behavior. Not one behavior proved, but a family of possible behaviors converging on the same visible outcome. Civilizations may be hiding. They may be minimizing waste heat. They may have abandoned bright radio for tighter, more directional methods. They may distribute infrastructure so thinly that it blends with natural backgrounds. They may build in cold regions, underground, inside asteroids, around dim stars, or in computational forms that consume far less obvious energy than human intuition expects. They may cloak activity deliberately, or they may simply evolve toward efficiency so extreme that distant detection becomes nearly impossible. The dark forest theory takes these possibilities and adds a motive. The motive is not elegance, it is self-preservation. A civilization that can choose between visible abundance and hidden sufficiency may, in a dangerous cosmos, choose the hidden path every time. This interpretation also gives a new meaning to the missing footprints of expansion. If the galaxy has had billions of years to produce technological life, then where are the settled frontiers, the modified stars, the great corridors of industry? A simple answer is that they were never built. Another answer is that they were built and then vanished. Yet the dark forest provides a third. The footprints are missing because leaving footprints is exactly what long-lived civilizations learn not to do. Human beings often think of power as display. Armies parade, cities illuminate, states mark their borders and celebrate their monuments. But display is a local strategy, useful when the audience is known and deterrence depends on being seen. In the dark forest, the audience is unknown. Display does not deter the unknown. It reveals value and coordinates. In such a setting, the most powerful civilization may not be the one that shines brightest. It may be the one that looks most completely like background. This possibility reaches beyond silence into the structure of anomaly itself. If the universe is a place where intelligence hides, then many natural-looking irregularities may remain forever ambiguous. A dimming pattern around a star, a peculiar arrangement of planetary debris, a statistically odd distribution of heat, a mismatch between chemical expectation and measurement. Any of these might be natural, artificial, or some mix of both. The problem is that a civilization attempting concealment would presumably design its activity to be mistaken for nature. The better the camouflage, the weaker the evidence. The stronger the evidence, the worse the camouflage. This creates a vicious epistemic loop. If concealment works, science sees only natural processes. If concealment fails, perhaps the visible civilization does not survive long enough to remain visible. Either way, the observational record stays quiet. The sky then becomes consistent with hidden life, in much the same way a forest floor remains consistent with hidden animals. Absence of sight does not imply absence of presence when presence has reasons to avoid sight. This logic does not convert ambiguity into proof. It does, however, explain why the dark forest can be so psychologically persuasive. Many speculative theories collapse because they require new evidence that never appears. The dark forest is more resilient because the missing evidence can be absorbed into the theory itself. No signals. That is what hidden civilizations would produce. No giant structures. That is what cautious civilizations would avoid. No empire-scale heat signatures. That is what efficient or concealed civilizations would minimize. No greetings. That is what fear would suppress. This resilience is also the theory's weakness, because it risks becoming too flexible. A model that explains every absence can slide away from falsifiability. Scientists are right to be wary of such models, yet even that caution cannot fully erase the uncomfortable fit between the theory and the visual character of the cosmos. Vast, ancient, rich in planets, and outwardly still almost entirely natural. The fit remains suggestive, even when it is not decisive. There is another unsettling feature to the silence. It is not only empty of alien declarations, it is empty of obvious ruins. One might imagine that if civilizations arise often and perish often, then the galaxy should still retain scars, broken shells around stars, system-wide debris fields, artificial isotopic anomalies, planetary surfaces transformed beyond geology, a graveyard of failed expansions. Yet from humanity's current distance and sensitivity, nothing of that kind stands out clearly. Perhaps such ruins are too faint to notice. Perhaps time erases them efficiently. Perhaps they are rare because most civilizations never reach large scales. Or perhaps, under dark forest conditions, failed or visible civilizations are not merely left to decay. They are erased thoroughly enough that little remains for distant observers to catalogue. This pushes the theory toward an even darker image, one in which the quiet is maintained not only by silence, but by clean-up. That image may be too far. It may overreach beyond what the evidence permits. Still, once the idea is allowed, it illuminates a subtle emotional truth about the paradox. Humanity keeps expecting the universe to show its history openly, the way Earth's geology, fossils and ruins show history on this planet. But cosmic history may be different. Space is vast. Processes are slow. Detection is hard. And if intelligence learns to conceal itself, then the visible archive may remain dominated by stars, gas, and gravity even when something else is present. The most important events may leave the least recoverable traces. The galaxy may therefore appear not merely silent, but innocent, as though nothing strategic has ever happened there at all. Against this possibility stands the scientist's discipline. It insists that natural explanations are enough until they fail. It insists that absence of evidence is not evidence of hidden hunters. It reminds the mind that the universe is already astonishing without adding secret wars among invisible civilizations. This restraint matters. Without it, the dark forest would become a mood rather than a theory. Yet the mood has a source. It arises because the observational facts are genuinely strange when set beside simple expectations of cosmic abundance. The galaxy should perhaps look busier. It does not. The sky should perhaps contain at least one unmistakable act of intention. It does not. The great silence may therefore be nothing more than rarity, or filters, or distance, or the youth of human science. But it may also be what silence looks like when it is maintained on purpose. If that last possibility carries any truth at all, then the quiet around Earth is not an empty stage awaiting a first word. It is a condition created and preserved by countless choices never heard. Civilizations may have reached the same conclusion again and again to last, become forgettable, to last, appear natural, to last, leave no bright trail. The stars then shine not as invitations, but as camouflage. Their ordinary light becomes the perfect cover for whatever learns to survive behind it. In that view, the silence is not a gap in the data. It is the data, interpreted differently, not the absence of a story, but the visible surface of one that refuses to speak its own name. At the edge of the dark forest theory, the mind arrives at the question it has tried to postpone from the beginning. What if the most frightening possibility is not that the universe is hostile in some theatrical sense, but that it is rational in a way human hope finds unbearable? That is the true sting of the idea. It does not ask the cosmos to be filled with monsters, conquerors, or civilizations driven by hate. It asks only whether enough minds, over enough time, discover that survival in a crowded and uncertain galaxy favors concealment, suspicion, and the removal of possible threats before those threats mature. If that conclusion is even partly correct, then the beauty of the night sky remains real, but the meaning layered beneath it changes. The stars do not stop being stars. They stop feeling neutral. They become possible masks. Every point of light may still be only plasma and fusion, yet around some of those lights there may be watchers who learned long ago that the safest civilization is the one no one can confidently distinguish from physics. And still, this theory does not close the case. That is important. The dark forest is powerful because it feels logically clean, but the history of science is full of ideas that feel clean and yet fail when tested against deeper reality. Many researchers reject the dark forest not because they underestimate risk, but because they see how many assumptions are packed into its apparent simplicity. It assumes that survival pressures remain dominant at all scales of advancement. It assumes expansion continues to matter. It assumes finite resources generate lasting strategic conflict instead of negotiated restraint or self-limitation. It assumes communication across light years can never build sufficient trust. It assumes enough civilizations think in similar ways for a common pattern of silence to emerge. It assumes concealment is practical, and that visible civilizations are either rare, erased, or more hidden than present astronomy can reveal. None of these steps is absurd, but none is established fact. The theory earns unease, not certainty. This is why many scientists continue to prefer other explanations for the Fermi Paradox. Some look toward rarity at the beginning. Perhaps life itself is astonishingly difficult to start, and Earth is not typical, but exceptional. The early appearance of life here may then say less about probability than about selection. Humanity can only ask the question from a world where life did begin, so the sample is biased from the start. Others focus on the long chain from simple life to complex, tool-using intelligence. Perhaps microbial worlds are common, and intelligent ones are nearly absent. Earth spends most of its history without anything like advanced civilization. For billions of years, life remains microscopic or simple by cosmic standards. Complex multicellular organisms emerge late. Technological intelligence emerges later still, and only in one branch among millions. This view does not require fear. It requires only patience and rarity. There is also the possibility of filters. Somewhere between chemistry and starfaring civilization, there may be one or several steps so difficult that very few worlds cross them. The filter may sit behind humanity, in which case Earth has already passed an improbable barrier and the silence is largely good news, or the filter may lie ahead, in which case technological civilizations often destroy themselves through war, ecological collapse, engineered disease, misaligned artificial systems, resource exhaustion, or social fragmentation before they become durable across multiple worlds. This explanation is grim, but in a different way from the dark forest. It turns the threat inward rather than outward. The silence then reflects not hidden hunters, but the difficulty of surviving one's own power. A galaxy can remain quiet if intelligence repeatedly fails its adolescence. Other explanations are stranger in softer ways. Some propose that advanced civilizations choose not to expand visibly because expansion is inefficient, undesirable, ethically constrained, or superseded by inward forms of existence. A sufficiently advanced society may prefer compact computational habitats, digital worlds, slow and stable local optimization, or modes of life humanity does not yet know how to imagine. Such civilizations would not fill the galaxy with monuments because they would have no reason to do so. Some suggest the zoo hypothesis, in which Earth is deliberately left undisturbed or unnoticed by a broader community, not out of fear but policy. Others argue that the search itself is still too young. Radio astronomy has examined only a tiny fraction of the relevant frequencies, times, sky positions, and signal types. Humanity may simply have glanced at the ocean for a moment and mistaken the lack of nearby ships for the absence of all shipping. These alternatives matter because they keep the dark forest from hardening into myth. They remind the mind that emptiness can arise for many reasons. They also expose a deeper problem with all attempts to solve the paradox too neatly. Human beings are reasoning from a sample size of one biosphere, one technological species, one short century of radio capability, one narrow band of instruments, one developing astronomy, one young civilization trying to infer the behavior of possible minds separated by vast distances and perhaps incomprehensible histories. Under such conditions, overconfidence is easy and dangerous. The dark forest may be persuasive partly because it speaks to old biological intuitions. It feels like an extrapolation of predator logic from Earth into the sky. That may be insight, it may also be projection. The universe has often turned out to be less human than human imagination first assumed, and yet even its critics tend to admit that the theory touches something real. Stephen Hawking, while never endorsing the full dark forest picture, warns that contact with advanced extraterrestrial life could be risky, drawing a comparison with encounters in human history where technological asymmetry rarely favoured the less advanced side. Other voices associated with the search for intelligence, including long-time figures in SETI, push back against fear and argue that silence should not automatically be read as menace. They point out, correctly, that there is no evidence all civilizations would turn paranoid, that cooperation can be advantageous, and that curiosity need not lead to conflict. But notice what this exchange reveals. Even the optimistic view must respond to danger because danger is conceptually plausible. The dark forest does not win by evidence. It wins by forcing every alternative to explain why visibility would be safe. This is where the theory becomes hardest to shake. It does not need to be certain to be consequential. If there is even a small chance that the galaxy rewards silence and punishes exposure, then humanity's behavior acquires a new ethical and strategic weight. Broadcasting becomes something more than symbolic outreach. It becomes a gamble placed on behalf of descendants who cannot opt out. Search programs remain scientifically valuable, but active signaling begins to look less obviously harmless. The issue is not whether fear should govern all inquiry. Fear is a poor master and often a worse scientist. The issue is that uncertainty cuts both ways. Optimism without evidence is not more rational than caution without proof. A species that has not yet established the nature of its environment may owe itself a serious reckoning before announcing where it lives. And yet even here the theory resists finality. Humanity cannot simply stop being what it is. Curiosity is not an accidental ornament attached to intelligence. It may be one of the very processes that produces intelligence in the first place. The desire to ask, to search, to test the horizon, to measure what lies beyond the next hill or the next orbit, is intertwined with everything that raises a species from local animal life to astronomy. To say that the rational action is silence may be true inside the theory, but it collides with a deeper reality. Civilizations that never look outward may never become civilizations capable of understanding the danger at all. The same curiosity that could expose Earth is also the source of science, medicine, engineering, and every instrument by which humanity has come to grasp the scale of the cosmos, the trait that may endanger the species is also the trait that makes the question possible, that creates a final tension the dark forest cannot fully dissolve. If humanity chooses silence, does it preserve itself or merely preserve ignorance? If it chooses outreach, does it invite catastrophe or take the first necessary step toward a larger truth? No available evidence can settle this cleanly. The radio sky remains empty of confirmed voices. The stars remain free of unmistakable megastructures. The exoplanet revolution tells humanity that planets are common, but not where the minds are. Atmospheric science may soon detect biosignatures on distant worlds, but biosignatures are not civilizations. Even if microbial life proves abundant, the paradox will remain. Life can be common and intelligence scarce. Intelligence can be common and visibility rare. Visibility can be rare because danger is real, or because no one feels the need to be seen. The dark forest therefore endures as the most terrifying solution, not because it is proved, but because it leaves almost nothing emotionally intact. If humanity is alone, the universe is lonely but survivable. If humanity is surrounded by beings who would destroy it from hatred, at least hatred is a recognizable motive. But if humanity is surrounded by civilizations that would destroy it from caution, from rational anticipation, from fear of future risk, then the universe becomes colder than malice. It becomes a place where even goodness may not matter if goodness cannot be verified across light years. In that reality, silence is not just absence, it is shelter. The blank radio spectrum is not disappointment, it is delay. The fact that no one has answered may be the luckiest fact in human history. Still, even this conclusion cannot be held without remainder. The night sky continues to invite wonder no matter how severe the theory becomes. People still look up and see possibility before they see threat. Astronomers still build better instruments. Space agencies still launch missions. Observatories still gather light from worlds circling other suns. The search continues because uncertainty itself exerts a pull stronger than fear for many minds. Perhaps that is reckless. Perhaps it is necessary. Perhaps the very tension between caution and inquiry is what defines a young technological species standing at the edge of cosmic awareness. The dark forest does not answer that tension, it sharpens it. It asks whether the silence is keeping Earth safe, whether the silence is merely emptiness, or whether the silence is the most disciplined behavior in the universe. It asks whether the stars conceal no one or everyone. It asks whether the greatest protection humanity has ever had is the possibility that, so far, it has not yet been truly noticed. And it leaves the final question hanging where it has been hanging all along, cold and unresolved above a small bright world that has only just begun to speak when the forest is this quiet. Is that because nothing is there, or because everything that survives has learned not to make a sound?